The new quite interesting effect in Blender is, as you see, quite interesting. This tutorial shows how I use rigid body physics simulations, camera tracking, keyframe animation and shape keys to create these effects. The animation of the picked up node and of the hand mask aren't perfect, but this is my first attempt. This tutorial is split into two parts. In the first, all the animated geometry nodes have active rigid body physics and act under gravity and spring constraints, and the keyframed animated menu stuff is done. In the second part of this tutorial, the node that is picked up has passive rigid body physics and is largely animated to follow the thumb. The rest of the nodes are still active body physics and so follow the movement of the picked up node, but are also influenced by gravity and spring constraints. All the materials for all these objects use emission, simulating the laptop screen, and no lights are used and is rendered in Eevee. Also set the blend node to alpha clip for all the materials, otherwise the animated geometry node planes disappear at certain angles and are even rendered this way. For the first part of this tutorial, I set the end frame to just before the thumb moves the picked up node, and masking is done in the second part. This is the screen backdrop at World Origin 000 and is scaled up 10 times to 18 by 10 meters, as I have found problems with rigid body world simulations when objects are too small. When positioning screen objects in their starting positions, I use the orthographic right view, so not as to bugger up the x coordinates of the various image planes. Bugger up is a technical Yorkshire term. I use the OBS Studio video recorder to screen record my clicking of Blender's file menu and moving the mouse pointer down to the quit option. Saving this Blender tutorial file, I then create a new Blender video editor to trim the start of the video to where the mouse clicks to make the menu appear, and end where the mouse click would click the new quite interesting menu option, and also cropped from the whole screen down to just the file menu. Opening the previously saved Blender file, I then added the menu video as images as plane. Need to enable the import images as planes add-on and set its X to 0.01 so it is just in front of the background screen. And set the material as emission. Then in edit mode, with all 4 vertices selected, I did a UV unwrap. Then in UV editor, crop down to the menu. Then in object mode, I just scaled and positioned the menu plane as carefully as I could in relation to the screen backdrop, again in orthographic right view. For some reason, I also needed to flip horizontally and vertically. I'm sure there must be an easier way of recording just the menu video, but this is the way I did it. Then in the GIMP image editor, I created a little ping image which I had a small screen capture of the mouse pointer in Blender. I needed to cut any image that wasn't and save as ping, otherwise you will animate the whole plane rectangle. This was added to the scene with X at 0.02, so just in front of the menu plane. I could have recorded the whole screen, but this gave me more flexibility and control for animating my mouse pointer. The mouse pointer needs to be where the menu clicking video mouse pointer is when the menu appears. I then keyframe the visibility of my mouse to disappear as the menu is clicked and the videoed mouse is seen and moves down the menu. I was going to use the animated mouse again later, but I didn't, as this was already a bigger tutorial than I first planned. My next tutorial does some fun things with this mouse pointer. Next, I decided the frame I wanted the animated menu plane to appear was 100 and keyframed its appearance in viewport and renders. And in the shade editor for the menu, I needed to set the offset for the menu video, which I thought would also be 100, but for some reason was -26, which I don't understand, but it works. Also keyframe a disappearance from render the menu plane to simulate the clicking of the quit or the to become quite interesting menu option. I didn't keyframe the appearance of my quite interesting menu option, but animated the amount of transparency in the material. This is just a text object that says interesting and placed at the end of the quit menu item. The blue backplane and 3 text objects are all parented to the off symbol. The off symbol is just these vertices animated with these shape keys. And the value is keyframed here to make the smiley face. Next, I keyframe animated my mouse pointer for the first 100 frames of the animation, moving up to the file menu plane and being where the menu plane recorded mouse appears. I then keyframed my mouse pointer to disappear. I also use the GIMP image editor to create pings for the animated geometry nodes from screenshots of Blender's geometry nodes editor, zoomed in on the individual nodes to ensure greater detail, using delete areas and the alpha layer to create the round corners of the nodes, even though they are simple square cornered planes. These pings are then added as images as planes and placed at 0.2 meters in front of the screen backdrop. The origins of these planes need to be in the middle, otherwise the following rigid body physics may simulate differently to the way desired. I also horizontally flipped these and colour inverted them for the back planes of the animated geometry nodes, so using 2 planes with the back plane at x 0.19 in front of the screen, and so just behind the front plane of the animated geometry nodes. I then parented these back planes to their corresponding front planes. These back planes don't need to be selected again, so in the outliner turn off their selectability so that clicking the front plane or back plane in the 3D viewport will always select the front plane, which will have the rigid body physics, rigid body constraints, etc. The links between the nodes are just planes at x 0.195, so are between the front and back planes of the animated geometry nodes. I created vertex groups for the end vertices, calling them pin 1 for the most left end and pin 2 for the rightmost end. Then I added hook modifiers to link animated geometry node's front plane object to the vertex group at the end of link planes. This needs doing for each end of all the links. Add rigid body physics properties of type active to all the animated geometry nodes front planes. Do this by selecting them all and then object rigid body add active. I changed the collision shape to convex hull and set the surface response friction to 1 to get the movement I like. I also enabled collision margin in sensitivity and set the margin to 0.01 to stop a weird twitching at the end of the rigid body simulation. With all the animated geometry nodes front planes selected, make a change and then right click the field and select copy to selected to apply and edit to all the selected. Then I selected the pairs of front planes that are linked and did a rigid body connect, creating a rigid body constraint between them. Then, for all the rigid body constraints, I changed the type to generic spring and enabled all these limits for X, Y and Z for all the angular and linear movements. I put all these rigid body constraints in a new collection and hid them. Next, I added this simple non-rendered mesh against which all the animated nodes will collide and simulates the laptop screen and where the bottom of the geometry nodes editor is and where the laptop's keyboard is. To keep this project a bit simpler, I kept the simulated laptop screen vertical and using a photo of my laptop from the side, imported as a plane to angle the simulated laptop keyboard angle. This means that the initial positions of animated nodes, etc. could be set in orthographical right view, and X was simply how far in front of the screen objects were. Add a rigid body physics property of type passive to this simple collision mesh. Then I set the start of the rigid body simulation to the start frame where the menu click of quite interesting would be. Bake in the dynamics for the rigid body world and the simulation gave this. I did several simulations changing the limits of the spin constraints, the weights of the active rigid bodies, friction and gravity to get a simulation that I liked and where a node ended where my thumb could appear to pick it up. Also, this is a fun thing to play with. Next, using my iPhone, I recorded this video for motion tracking. I used the Filmic Legacy app, recording at 1080p filmic quality at 60 frames per second. I also used cinematic stabilization, but it is still quite jerky, but okay for this tutorial. I recorded this in a conservatory to get good daylight. Several previous recordings at night using room lighting proved bad for motion tracking. I recorded extra footage at the start of the video which gave the flexibility to set the start frame of the footage so that my picking up of the node occurs nicely after the first rigid body physics simulation has come to rest. I used to think that camera or motion tracking in Blender was a bit of a dark art, which I struggled with for ages until I watched all 10 of Helge Mauser's of pixeltrain's comprehensive videos about this. There is a link in the description. Another good source about camera tracking and shorter is by Jacob Zirkle. Again, there is a link in the description. As these resources are so good, I will just say I used automatic feature detect, track until there is only a dozen trackers still working, go back a few frames, and then auto detect features again, select all the trackers and track again. For solving, I used 100 keyframes towards the end of the footage. First solve error was 1.0. Clicking clean tracks and then in the operator panel changing error, I delete all errors above 5 and the second solve was 0.6. Refined for focal length, optical centre and radial distortion, and the third and final solve was 0.25, which is one of my lowest solve error. Set up tracking scene using tracking points on the laptop screen. Set wall, origin and y-axes. Then, back in the layout workspace, I scaled and orientated the camera solver object constraint camera so that the simulated laptop screen lines up nicely with the filmed laptop screen. I started by enabling motion tracking in overlays so I could roughly orientate the camera. There is a bug in Blender 3.4.1 in that I can't change the size of the tracking points. And then with two 3D viewpoints, one the camera's view and the other to manipulate the camera, I fine-tuned the camera so that the simulated screen nicely tracks the videoed screen. I then rendered the first video up to the point where the fallen geometry node is about to be picked up but is not obscured by the thumb. All the nodes having active rigid body physics and falling under gravity. As I'm only using emission materials and there are no reflections, I only used 16 samples in Eevee and was happy that the render only took about 20 minutes. In the second part of the tutorial, I set the start frame to where the thumb is about to move over the node and end frame at the end of the footage. I applied visual transforms for all the geometry node front panes. This allows the rigid body simulator to be started again with the nodes starting from their fallen position as they are picked up. As mentioned at the start of this tutorial, in this second part, the picked up geometry node front pane has passive rigid body physics. This is parented to an empty that is itself constrained to follow a camera tracker that follows the thumb. Back in the camera tracking workspace, I create another tracker on the thumbnail. I got this to track through all the footage. I was surprised how well this worked and thought I would need to reshoot the footage with an ink dot on my thumb, but this wasn't needed. With this new tracker selected, click Reconstruction, Link Empty to Track. Back in 3D view space, you can see the new empty follows the thumb from the camera's point of view, but Blender has no depth data for this point. For this tutorial, I created a large vertical plane whose X is that of the picked up node at rest, which covers the view area from the camera in which the thumb travels. This plane is hidden and not rendered. Add an empty and give it a follow track constraint, whose track is the tracker that followed the thumb in camera tracking. Note the list is not numerical and is the order of the created tracks, so you have to scroll right to the end of the list. And set the depth object to the large vertical plane just created. You can see this new empty follows the thumb correctly when viewed from the camera and is positioned at a sensible distance, and although it doesn't move in the x-axis, depth from the camera, this is not a problem for this animation. Depth movement could be created by editing the depth object. The reconstructed empty from camera tracking can be deleted. I only used it to show how this all works. Next, set the start frame to where the thumb is about to pick up the node. Then select the picked up node's front plane, which has the passive rigid bodied physics, and then the empty with the follow track constraint, and parent them. In order to get the rotation of the front pane node, it is easier to use the local transform orientation and the rotate object cursor to alter the X, Y and Z angles in the sidebar panel. And keyframe them. When I tried altering them in the 3D viewport, all kinds of weird rotation animation happened. Delete the baked dynamics for the rigid body world and then rebake all the dynamics to animate the linked active rigid body physics nodes so they follow the picked up passive rigid body physics node. I was happy with this movement, but you can of course change the generic spring constraints, node weights, etc. to get a different simulation. Even though the picked up node is being animated, it still needs passive rigid body physics for the spring constraint to the next linked node to work. To stop nodes going behind the simulated screen, I simply extended the simple collision mesh to keep all the nodes in front of the screen. Next, I needed to create the mask for the hand, so I set the start frame to where the thumb is about to move over the node and end frame before it moves. So the picked up node doesn't move incorrectly before being picked up, I deleted its parenting to the thumb following empty just for this part. In the masking workspace, I created a mask for my hand. No nodes can appear to be in front of my hand, but I'm okay with that. I also added a few pixels of feather. With the new thumb following empty selected, I went back to the mask workspace and with all mask points selected, click Parent. Enable auto keying, and now I went and tweaked the mask after moving through the footage and doing several test renders and readjusting the mask as needed, up to the point where the picked up node moves. Render this bit of animation. This tutorial uses 3 rendered videos. Then I set the start frame to where the thumb starts to move the node and end frame to the end of the footage. Select the picked up node front pane that has the passive rigid body physics and then the thumb following empty and parent them again. Back in the mask workspace, I tweaked the mask for the rest of the footage. It's a bit of a chore, but a lot easier than only keyframe animating a mask without parenting to the thumb following empty. Then in the compositor, I set these nodes to make the mask work with the rendered layer and its alpha and of course the original video. I did try sculpting a rough model of my hand and using a holdout material instead of using a mask to obscure nodes and to make it a passive rigid body so nodes would bounce off it, but quickly gave up on this as it was taking too much time. The third render only took about 40 minutes, and then I used Blender's video editor to stitch the 3 videos together. In conclusion, I think I should have actually picked up a small piece of cardboard with a mark on it, which might have made this a bit easier. I really hope some of this is interesting or useful and welcome any constructive criticism. If you would like more tutorials, then please subscribe. Thank you.